What's a rescue motor used for? Why do I keep a rescue motor with me? How do you know if you have a faulty ECM motor? How do you diagnose that? And how do we put in a PSC motor in the place of an ECM motor? You're watching Taddy Digest. This is HVAC Tips for Technicians. I'm Tad. Let's get started. We're looking at a Rheem 3.5 ton package heat pump. And this package heat pump has a 3/4 horsepower 230 volt ECM motor. So I got a motor with a module, and this motor is faulty and it needs to be replaced. So today I'm taking it out because after we called the distributor and asked for a new ECM motor because this one's under warranty, they said it's on back order and there's 4 or 5 people in front of you that need this part and we can't give you an ETA. So without an ETA, I can't help my customer. So I carry a rescue motor, which is just a universal motor that has a bracket already on it, a motor mount, and I can take this, I can put it in place where that ECM motor is, and then I can get the customer back up and running temporarily until their new motor comes in. So we're going to look at the schematic and look at the wiring for that motor, and then we're going to give it a call for a fan, and then I'm going to show you how to know if it's bad. On the schematic, we can see we have our IBM, which is indoor blower motor. On the left, you've got your common, which is one side of your 24 volts, and then you've got your 1 through 5 fan speeds. So right here, we can see we have the other side of the 24 volt. So between C and 2, whenever we have 24 volts, then that is a call for the fan to run. Now we have an L and an N, which is our power. This is 240 volt between L and N. And that motor will always have 240 volt, and then it has a ground. But between C and 2, we should have 24 only when the motor is supposed to run. To get a better look at the terminals, because they're on the bottom, we're going to take this whole housing out. So we're going to take our drill, 5/16, and it looks like we've got one screw here on this side of the housing. Got one screw back here. And then looks like we got one more here. We can't get to that one. So we're going to use our 90-degree adapter here. And it looks like this will, yeah. Motor will slide right out. All right, let's take a look. Now let's verify we have 24 volts, and then let's give a call for fan to run, and then let's check the fan motor and see if it's running. So we go from C to R, right, to see if we have 24 volts. Do we have 24 volts? Yes, we have 27 volts. If we go from C to G right here, which is brown to green, see that brown to green wire? We should have 24 volts if we put R to G, but we don't. All right, now if we take a look here from R to G, or red to green, we should have 24 volts, right? Because the motor doesn't have a call. We're going to give the call to the motor though. Watch. We go from red, we put the red and the green together. Oh, you hear a click? Because there's a relay that closes. Hear that? And that relay is what sends that 24 volt signal to the fan motor. Right here, let's go to the motor. So see the motor? We got 1, 2, 3, 4, 5 up here. These top terminals. 1, 2, 3, 4, 5. And we got this green and black wire on the number 2, which is probably low speed or medium low. Then down here, we've got a brown wire, which is common. So between brown and green and black, we should have 24 volts now, right? And then we've got 3 wires here. Black wire, which is on the terminal labeled L, and then orange wire on the terminal labeled N. So between black and orange, we should have 240, and then this is our ground wire on the terminal labeled G. Now, first thing we're going to do is we're going to check our 24 volt call. Now let's check the call to the motor, 24 volts. You see you got a meter on volts AC, and we're gonna take and put one lead on that brown wire and one lead on the green and black. What do we have? 26 volts. All right, now we're gonna take and put these back. Brown goes on common, green and black goes on 2. We're gonna pull off our high voltage wires, L and N, or black and orange. We take and put our meter leads in between. And what do we got? We got 248 volts. 248 volts. You see that? All right. So we got our high voltage to the motor, and we've got our call for 24 to the motor. And what is it doing? It's doing nothing. Change speeds. Does nothing. So what does this mean? It means this motor is bad. So we have a rescue motor. We're going to go ahead and take this motor out, and let's put the new motor in. The first thing I like to do is turn it over, and I like to take some sandpaper and sand the shaft. Not a lot of shaft is sticking out on the other side, so that's nice. It'll be easy to get this old motor shaft to come out of that hub there. I like to spray a little WD-40, and usually before I do that, I'll take and loosen up the set screw, right? So loosen up the set screw with adjustable wrench, spray it with some WD-40 here all over, and then we'll turn it over and take these bolts that are holding the motor mount and loosen them up. Got a 7/16 socket, and I've got an adapter in my drill for the socket. Always pay attention to which way the plug is for the motor, and I always like to make a mark where that plug is. That way if I'm putting in another ECM motor, I face the plug the same direction. That way it's easy to reach. Now, flip this over. And then the most important part is I like to take my wrench, put it on the shaft of the motor, and then hang the housing to where that motor will drop. And then I'll take and spin this shaft. Take a look. Just spin that shaft back and forth, because as you spin that shaft, it's going to drop. Got my hammer. Put this right here. Before you do that, you may want to put a little bit more WD-40 on there. Motor's out. I could take this motor mount off, but I've already got a motor mount ready to go for my motor, so I'm probably just going to take and flip this over, put it in place. Alright, new motor. Try to line up the flat part of the shaft with the set screw. That way it goes in really easily. There it is. And push it on down. Oh, and it looks like this motor mount will not work. I guess the other motor mount, the arms are a little bit longer, so I do need to swap out motor mounts. Taking the old motor mount off. I'll have to cut that zip tie. New motor mount. Make sure you got a 7/16 socket. Make sure you don't use the old pieces of the motor mount. There, that's pretty much in a good spot there. Tighten it up a little bit and then pull it up to where you need it. That looks pretty good right there. Tighten it up some more. Put these in place. Looks pretty good. All right. New motor mount is in place. Shaft lined up. Now, this will line up. Beautiful. I'm going to take and cut this zip tie, and then, of course, we can put these in place now. Got that wire tie in a second. I'll go ahead and tighten up the set screw though. Now before I tighten up the set screw, I always take and look at the wheel, right? And I want to even it up in between each side, right? So I can't push it all the way in because look, there's no room on this side. There's a lot of room on this side. I want to take and put it right in the middle. See that? That's about right. See, we got area over here. We got a little bit of area over here. Now I can tighten this up. So if you take a look, see how it's not even? The set screw is not lining up with the flat part of the shaft. I want to take a flathead screwdriver. I'm going to take and turn this. Now it's pretty even. Well, maybe go back a little bit. All right, now that's even. Tighten up that set screw. All right, set screw is tight. All right, there we go. Spin it. Make sure you don't hear anything hitting. Now, new motor is ready to go in. Motor's mounted in the housing. Now let's look at what size capacitor we need and the wiring and what fan speed we'll choose based off of the rating of the old motor. So if we want to use 3/4 horsepower, we need to use the black wire for cooling, and we need to use the medium low for heating, or the medium high, which is blue. So I'll probably be using the black. And then I'll be using a 10 microfarad capacitor. And then I should expect my full load amps to be around 3.9, right? So if I was using 1/4 horsepower, I'd be using the yellow speed or the red, and then I'd be using a 5 microfarad. We look up here and we've got our counterclockwise, and we can change that by changing this. Okay, so we can make it clockwise or counterclockwise. And then we look over here, and this is our wiring. So we've got white, which is one side of our power, and then one of our speeds. And then we've got brown and white going to our capacitor. So we've got our capacitor here, 10 microfarad. I'm going to route these wires through this hole, and then I'm going to show you how I'm going to wire this up so we can have heating and cooling when we need it. I've got the wires routed through this hole here, the wires that I need, the white and the black. So where are they going to go? Take a look here. We got this contactor. This is the line side of the contactor, and this is the load side. And whenever this contactor energizes, the coil receives 24 volts. Then the contacts close, and it sends the power from the line side to the load side, and that will give power to the compressor and the outdoor fan. So I'm going to take black and go to one side of this contactor. I'm going to take white and go to the other side. And then whenever this contactor closes, it will send power to this PSC motor. The other two wires I've got here are for my capacitor. Brown and white. I need to mount this. I need to wire tie all of this. And then we're going to be able to energize the contactor coil, let it close, and then I'll be using a meter to test the amp draw of the fan motor. Now I've got all these other wires secured so they won't go into the fan blades or the wheel. Now we need to make sure that when the motor spins, that it spins this way, right? Because you can see that if it spins this way, then it's going to scoop that air and it's going to go into the house, right? And if it spins this way, it's wrong. So we're going to test it out. Let's go turn the breaker on and push the contactor coil in, or contactor in. All right, let's see which direction the blades spin. It looks like it's spinning the right direction, right? Let's wait till it stops. Always use caution, and it is spinning the right direction. So we don't have to switch the direction, but I'll show you how you switch the direction real quick here. So you just take this, take it out, you turn it and put it back in. Be very careful when you're messing with HVAC equipment or anything electrical. Turn the power off. Just be careful. All right, let's mount the capacitor, and let me go ahead and read the amps on the motor while it's running. Let's give the system a call for cooling by touching the R and the Y, the red and the yellow together. Fan spinning, it's working. Let's take our meter and put it on volts AC, and then hit the select button. And now we're going to take it up here and measure one side of the power going to the motor. What's it say? 6. Why does it say 6? Let's measure the black. What's it say? 6.3. That's way too much. Why does it say that much? We need to put the panels back together, then measure the amp draw. Let's go ahead and do that. Thermostat set to cooling. I'm going to go ahead and show you the inside of an ECM motor so you can see what part actually failed. So this is the rotor, right? Because it spins. These are the bearings. Look at the bearings. Bearings aren't bad. Then you've got the stator, right? So this makes up this BLDC motor. And then this is a plug that leads from the windings and plugs into what's known as the module or the motor controller. This right here is the part that most commonly goes bad. If you could order this, you could just replace the module. Sometimes you have bad bearings, but not normally. And this unit, let's take a look at the model number. Let's see. It is a 43, so, 43,000 BTU. And then it's a 2015, so it's 9 years old, right? It's 2024. This is 9 years old. Unit is working in the cooling mode. Let's take our meter, turn it to AAC, hit the select button. We should have about 3.9. There's one side, 3.8. And then here's the other side, 3.9. Look at that. Now let's look at the service facts or the data and see what the old motor would have been pulling. Indoor blower, 6.0 full load amps. So if you put in a new motor and you check the full load amps and it is a lot higher, then that could cause your motor to overheat. There could be a problem. Check the ductwork. Check the filter, check the coil, see if it's dirty. I've got a video on how to replace a ECM motor with a PSC motor using a type of product that actually mounts in the unit and has a board with relays. If you want to learn more about that, I'll put a link to that video right here. If you want to learn more about relays, transformers, contactors, I've got a video specifically teaching you about relays and transformers, and I'll put the link right here, or you can go check out the link for those two videos. I hope you enjoyed this video. I hope you learned something. If you did learn something, let me know what it was down in the comments. If you've got a question, remember questions can lead to new content, so ask your question down in the comment section. But if you don't have a question, that's okay. Let me know who you are. Let me know where you're from. If you like the video, hit the like button, subscribe, smash that bell, ding, so you know what I'm doing. If you want more videos like this, go check out my playlist, HVAC Tips for Technicians. I've got hundreds of videos of live experience as a technician in the field to help you learn how to be a better technician. You've been watching HVAC Tips for Technicians. I'm Tad, this was Taddy Digest, and I'll keep you cool if you let me.